welcome everyone to this yet another webinar from us for you. Today, the topic of the webinar is going beyond Satori, extending your data visualization and analysis capabilities. And I'm very happy to be joined by my colleague Armin. There he is. Really excited to have you here, Armin. As many of you will probably know, Armin is our Satori specialist and scientific support consultant. So really excited for you to share your knowledge with us over this next hour, Armin. As per usual, let me say a couple of words for the introduction. Most of you here will probably already know most of this, but as per usual, introducing the company really quickly. We are NIRx, based in Berlin. We have been a provider of high-end FNIRS solutions, both hardware and software, for over 20 years, supporting researchers such as yourselves in the research process and helping you to get from system acquisition to publication as quickly as possible. And part of that is, of course, our offering of awesome analysis software such as Satori. We put a big emphasis on support. Again, hopefully this webinar shows this, and yeah, really excited to keep building on this today. You can always connect with us either via our website or just by writing us an email to consulting@nirx.net or via all the most common social media platforms. If you wish, you can subscribe to our newsletter to be kept up to date on our latest product features and releases, including, for example, Satori updates, featured user research, and other exciting news around NIRx. We promise we won't spam you. You will receive an email only once every couple of months with the most important stuff. Considerations for this webinar: as per usual, you are muted. Questions are, however, welcome at any time. You can type them into the chat window. We will make this webinar available on our website in the upcoming days. And for any further questions, you can, as I said, always contact us via website or our email address. And any questions that we don't get to today, as I said, please feel welcome to just contact us directly. Now I would like to introduce to you Armin. Armin, really excited to have you. Armin did his degree in psychology at the Technical University in Braunschweig. His interests and, as he likes to say, hobby are experimental design, methods, and statistics, among many other things, of course. Armin did his PhD in 2000 on the topic of subliminal processing and attention. He has worked as a support consultant at Brain Innovation for many, many years, where he focused mostly on fMRI analysis using Brain Voyager. And he started with us, with NIRx, as a scientific support consultant in March 2022. And he is our, as I said before, Satori subject matter expert. And yeah, with this, enough talk. Armin, take it away and enjoy the webinar.
Yeah, thanks so much, Franzi, for the nice introduction. I hope I can justify it. First, I would like to thank everybody for joining, and of course, NIRx for allowing me to present this very exciting topic. And of course, I would like to start with a little bit of an introduction from my side. And as usual, it's a bit on the funny side. So I hope most of you can make sense out of this image. But if not, I can explain it to you, because what you're seeing here is yeah, not very artful, but interesting looking AI depiction of a song from the British pop band The Police from 1979. Released in the second album, Regatta de Blanc. And it's a seminal song about yeah, communication problems and alienation in the modern world, so about loneliness and communication. But you might ask yourself, why the heck do I show you this picture? Because the topic of today is, of course, that we want to send something away. So we, based on the Latin verb exportare, we want to send data away out of Satori. But of course, we also would like to get something back in the end. So the next couple of slides, I would like to show you that what we're looking at is not just a number of limitations that are proving to you that the software is limited, which of course it is, but I want to make sure that to explain to you that this limitation in the end can become a strength. So from weakness, you can get a strength, because if you learn the proper way to easily access and export your data, you also gain on the other side nearly limitless capabilities to analyze and visualize your data beyond what you have in Satori. And so in principle, the motivation is, of course, if you think about it in a more general way, of course, any analysis tool has to be limited. So it doesn't matter where you start with non-commercial or commercial software, everything is limited, has to be limited. There's no way around it. And of course, you might think of cool analysis methods that we never thought about in our life. That means you might think of cool things that we might only understand a little bit later after you informed us about it. So there's always this very important interaction between user and creators of the software. So it means by being able to export your data or parts of your data, you can do cool things that you could only dream of before. And you could help other people to achieve the same goals. And of course, there's always constantly new methods being created. So most of the tools we use nowadays are, of course, fairly old, developed even in the last century or so, so general statistics. But from time to time, new tools are coming up. I can give you some examples, but in principle, the idea is only by being able to efficiently export and analyze your data externally, you will also be able to follow new trends and to do new cool things which haven't been known in the last couple of years. Good. So we can all agree on that very simple and effective export and external analysis tools are important. And of course, what we need is something more like a pipeline, which is very clumsily visualized in this boomerang coming back to Satori. But the basic idea is you don't just want to send something out like the message in the bottle in the song, but you also want to receive something back and probably depict the results of your analysis that you do outside back in the end on the nice brain visualization, the 3D view in Satori. So feedback loop is really necessary. And I thought about a couple of options that's by no means a complete or holistic depiction of what you can do, because basically the sky is the limit. So I don't know, of course, what is installed on your computers, what software tools you used in the past for FNIRs or other data sets. That means this is just a quick view of what some stuff I tried in the past and other might have also tried. So you can easily export your data and then, let's say, just export a time course, open it up in Excel. How does it look like? Can I make the same plots as in Satori? Can I make better plots? What happens if I import the data in a statistical tool like the freeware tool JASP? What statistics can I do there? Can I, for instance, test the assumptions of my GLM? Can I look at the residuals? Can I test the normality assumption and such? And there's, of course, many options via MATLAB, and many of the freeware tools run only in MATLAB. But what I'm now talking about is the idea that using the Python interface in Satori, you can not just easily export your data out of Satori, but also bring it back to Satori in the end. So that's what hopefully is understood at the end of this webinar, that the door swings in both ways, so to say. To cite one of my favorite movies, that this option should be going in two directions. So let me first show you some simple levels of export of data from Satori that you have anyway by just opening the tool, loading a data set, and then going to the export menu. And I want to classify things a bit to make it a bit more clear. So I try to bring it in a bit of a structure, because in principle, you can export everything. But of course, especially when you're beginning with Satori or with your data analysis, you might be overwhelmed by the multitude of options. So it means it's very good to get a taxonomy of things you can export in your mind, and then to decide better what is the best for me to export for my analysis I have in mind. And of course, what you can in principle do is you can export data based on all the channels in your data set. So load a data set with 50 channels, and you want to export this data set for all of the channels in one sweep. This would be these two options. So export ERA data and the frequency spectrum. This would export everything you have in your file for these two parameters. On the other side, you have selected channel exports, which just means you export from a single or multiple selected channels. So you click on a channel, you control click on a second and third channel, so you have 3 channels selected in total, and you just export, for instance, the event-related average data for these 3 channels. That might be very interesting, especially for people who want to just look at regions of interest, and they're not really interested in further analysis of all the 47 other channels, but just the 3 selected channels via the mouse click or via function to which we come in the end. So it means this is a general distinction for data export, looking at everything externally or just parts of the data. Of course, in principle, the selection could be done outside. So after exporting everything, you could externally write a function to select 3 out of 50 channels. But just to let you know, this is where we start. So when you think about the levels of data you could export, not the so to say, the parcels of data, but the levels of data, let's start in the beginning. What you're usually starting with is your time course. So the FNIRx time course, OXI, deoxy, total, you want to export, you get just a time course of 1 or multiple channels. Based on this, what you get is, or you could get what I call derivatives of the time course. And derivatives in this case means you calculate something new on the basis of the data. And this something could be an event-related average. So a very simple version of making the data much more simple, but very easy to understand and very easy to check in corresponds to your design, to your task of interest. So you just create event-related averages. And based on these, there's also in the more recent Satori versions, the area under the curve, which is another version to just get a single number that characterizes basically the bump depicted in your event-related average. So that's another way to simplify the data even more. On the other side, in B, you have the frequency information, which is also very important to understand, for instance, what are the represented frequencies in my data, especially how do they look before to after the preprocessing, how does my data change in the frequency domain, not just in the time course domain. Thirdly, you have what I call extracts. So sorry for the terminology, but that's something I came up last night. Extracts in this case means you extract non-inferential data, so non-statistical data. So this is a data set that you cannot show to anybody and claim, this is what I publish now, this is my relevant data, because something like beta values are unitless regression coefficients. So they can be very small or very big relative to what you do before to your data and to your model, but they're still relatively informative, especially to feed them into other analysis types like ANOVAs, like correlations, like correlations with external covariates. So these values are very important, but they should not be overestimated. So I would call them or classify them as non-inferential. And fourthly, you have really inferential outputs, so really parameterized statistical output like t values or r values mostly in Satori. So those can be exported and can be used directly in a scientific communication, because a t-value in combination with the degrees of freedom gives you a statistically meaningful information that you can immediately communicate. But you can still use them for other techniques, at least in the field of depiction. Then additionally, as a side effect, you also have surface maps you can export from Satori, and they are especially important, not just by themselves, but also in combination with, for instance, additional analysis types like fMRI analysis, because if you have these surface maps, you can depict them also in combination with surface maps created in Brain Voyager for fMRI data, and therefore check the consistency between the outputs in these two modalities. So let's break the data down. So let's look at a single channel data set here, the OXI data for one simple single channel in the finger tapping task. You can break it down into the event-related average and the frequency spectrum. This is something you would now easily export, and you just get usually a CSV file containing all this data. And we come to an example in a minute. But when you look now further at the event-related average, and this is an idea that came up, of course, a long time ago, but it was recently brought to my attention again by the workshop Red and Bari, because somebody was asking for those details, and maybe some of you are also interested in breaking this further down. If you think about this temporal dynamics of the event-related average, so the most simple thing you can think about, just taking your data segments and average them, synchronizing them, and just showing one curve to then compare it to something like a classical hemodynamic expected response, you can still break it down into relevant parameters. For instance, one thing you could do is the area under the curve. So in green and orange here, you see the corresponding areas under the curve for the, let's say, left and right finger tapping in this case. And you see there's a massive difference between these two blobs, which can be boiled down into a single number that could be compared. And this single number, again, could be put into a statistical analysis in the end. So everything I'm talking about also can be generalized into the multi-subject domain. So it's not just to export something, but then also to use it reasonably in statistical analysis further on. The second thing you might be interested in is the time to peak and the peak value. So what are the numbers that characterize the peak in a certain function, and when does this peak appear? So breaking down the temporal dynamics into these specific parameters. And you could go even further, which is not in this graphics, but you could also be interested in what's actually the time to peak for OXI and deoxy, so for the two different data sets you collect? Is there a significant difference in a channel or in a set of channels? Or is it all fully symmetrical? And if so, how different could it be? But these numbers can be easily extracted. And then to go one step further, you can now go on and calculate new statistics on the basis of these simple parameters, namely something like the so-called contrast to noise ratio, which usually is some ratio of a temporal mini time window of the peak period divided through the some measure of variance in the baseline period. That means the only thing you do is you tell your algorithm, this is my baseline period from -5 to 0, and this is my peak period from, I don't know, 10 to 15 seconds post. So you can choose whatever you like. So an algorithm is usually flexible, but then you can calculate the so-called contrast to noise ratio. We come to this in a minute. So now let's go back to close it up. How's the pathway back in Satori? So if I do external calculations, extract all these values, how do I get them back? What is very critical here is the CMP or channel map format, which can help you in the end with the help of an algorithm, of course, to take the data that you see on the left, which is now a CSV file created by a Python script on the basis of our data. We have to bring it back somehow to the format that is shown on the right, which is just a CMP format opened up in a text editor. So you need to bring the numbers from the left to the right. This is basically the job that you have, but that you shouldn't do in any case manually. Never do it manually, but do it by a script, because then you can easily, of course, do it in bulk. So you can do it for 100 subjects, but you can also easily adapt it in any way you like. So now let's go to examples, exporting time courses. So everything I show now is based, it's important to note, on the basis of the fresh data set, the fresh audio sample. It's, of course, an important study that has been published only a couple of years ago, but was used for testing the reproducibility of FNIRs data by many labs and many researchers. And there's a very recent paper from this year where multiple labs combine their results and show you how difficult it is to replicate results in the FNIRs domain, which doesn't mean it's a bad measurement or it's hopeless. On the contrary, it means actually that we live in a realistic world where expectations should be maybe minimized according to the statistics. But we can come to the details. But everything I show now is from this data set, and you can easily also download it from this link and can do all the steps I showed you myself. If you want to export the whole data set in Satori, you can do it easily within the SNIRF editor. So if you click the Show SNIRF button on the right, you can, of course, visualize the whole SNIRF file. And you can go through all the levels of this HDF5 format. You can look at the time courses. You can look at the auxiliary measures like physio data or accelerometer measurements. You can visualize everything. But you can also very easily save this whole data set as a CSV file. And this then usually looks like this. You get this new CSV file, which in this case are called subject1 raw data. And depending on when you export it, you might just get the raw wavelength data, or you might also get OD and CC data. So you might get a bigger or smaller data set. It usually looks like this. I open it up in Excel, and you see there's a very nice header there. It's usually sorted in a certain way. It's very important, of course, for you to understand how is my data sorted, because only if you understand how the data is sorted and you can properly read the labels from this very nice row 1, you can, of course, understand, okay, it's actually basically all the same channel, but then for oxy, deoxy, and total, and only then the second channel is coming. So first it's the chromophores, then it's the channels. It might be sorted in other ways, right? But you can see it in the file, luckily, and your script can help you understand that. There is now, fortunately, with Python, other ways to export your data. Let's say you want to break your data down in different ways. You could do this immediately with a Python script. And I have this little example here with a so-called SNIRF reader Python script, which I copied into the Python path of Satori. So after you start Satori, you see now it reads the path and it reads the folder and shows me the script is in there. I can start it from here. And what I then get is a bunch of files, because I wrote the script, or I decided to let the AI wrote the script, to be more honest, in a way that I export all the different parts of the data in different CSV files, because I like this more. I like to have more multiple files than all in one file, just my personal opinion. But you can do it differently. So if you do it, you can choose whatever you like. But you see you have SNIRF time courses all, which is really everything in one file. But you also have here the SNIRF time courses oxy, which is more important for me if I want to specify on the oxy. And if you open it up, you see in my case, the data is sorted differently, because you have first the channels, so S1, D1, S1, D3, and so forth, all oxy. Then there is maybe something else, or it might be even only oxy, like in my case. That means I simplified to the max. because my additional analysis techniques, they rely on how I export the data, because I try to streamline it as much as possible. Good, let's look at the derivatives, as I called them, for instance, the frequency spectrum. You can export the frequency spectrum for selected channels or the whole data set, as I mentioned, but maybe you want to make your own depictions of the frequency spectrum, because sometimes it's easier to look at data in different ways. So just one example I show you here now, I use the exported frequency spectrum, again, here opened up in Excel. So you have a frequency column, and you have then all the OXY channel data for the frequency spectra, and you can then use the Python script to plot your data like this. And what you see now is on the left side, the raw data of all the channels of a single subject data set. And on the right side, you see the same data set after the preprocessing. And the only thing I did now is I did no own calculations. I just loaded the data from what Satori did. I created this depiction, and I added the marked bands in the background, which are labeled according to standard frequency settings. So basically what you see there is, for instance, where would I expect the Mayer wave range, where would I expect respiration, where would I expect the heartbeat, and where are the so-called very low frequencies. And what you can clearly see, there's a massive change between the raw data set and the preprocessed data set, which is absolutely expected. But this is more like an evaluation of the quality of your preprocessing. And this might change differently in different subjects, but in principle, there should be a massive change usually to be expected for whatever preprocessing steps you do. But for the standard pipeline, you would expect these changes. But to be honest, you can create better plots. This is just one example that you could easily create, already improving what you saw before maybe. So now we look at the signal to noise ratio, which is another simple quality evaluation of the data. You can imagine as the quality of your data, even without any look at the design or at the task. You just look purely at the simple ratio of some measure of the mean activity versus the noise in the data, and with a normalized term. But in principle, what you can also now do is you can use this little script, run it, and you get just a measure in decibels, SNR, which tells you, for instance, in this case, for all the channels in the data set, what's the dB value in the data set over all the channels. And because you have the data now like this, you can also depict it like this. So if you more like something like a box plot, you can, for instance, check, are there any outliers in the data with respect to these values? And how does my data correspond to data reports I find in the literature? So if anybody else reports these values, which often is not done, but you could find a paper of people that do this, you can immediately compare them, because this measure is immediately comparable if it's calculated in the same fashion. So of course you always have to compare how people does it, but this is a quite standard formula. It's of course very, very simple, but it can also help you in an operation, for instance, where you compare different devices, or where you compare a new device that you just acquired and you just want to check what's the quality of what we measure here. So of course you have all the other measures that we provide you with Aurora in the calibration stage, but this is now an additional measure you could check on the data side after recording your snare files. Now I show you, for instance, now going to the multi-domain data of this fresh sample for 10 subjects. So you see on the x-axis 10 of the 17 subjects. You just see their box plots, here box and whisker plots for the SNR that they calculated in a simple way. And you can clearly see it's overall, it's fairly nice. It's also measured with a NIRx device in this case, but you can apply this to any data coming from any device, obviously. But you also see potentially some outliers in the subjects. You might find some subjects are different from others. Why this is, we don't know, but it's always good to have this information to act upon it later. On the lower plot, you see again the channels on the x-axis, and the error bars show the variation of these data points over in the pool or little sample of my 10 subjects. So you see that there are some channels which are better in quality, others a bit worse, but in principle, the overall quality is absolutely okay. While you might find sometimes data sets where this drastically is reduced for some reason whatsoever, but at least now you can see it, visualize it, and check it out. Okay, let's look at the event-related averages, going one step down from the time course, as I mentioned before. And I mentioned we have now these different parameters we can check. We can check the peak amplitude, we can check the time to peak, or the contrast to noise ratio. And in this case, I plotted also using a Python script the expected hemodynamic response function, because sometimes you just want to see how close is my event-related average to whatever data I would expect from the model. And of course, the model is just a model, so it's not perfect. It's just a simplification of the world based on our assumptions that are potentially wrong, but not totally wrong. So that means we have at least something to compare to. And the basic idea is now we look at those different measures and or 3 different measures, and also do it in a scripted fashion. And what I do here is I now first start with plotting everything. So I took again the 10 subjects and exported the event-related average data for one channel, which is here over an area that should work with this auditory design. So it was listening to speech, or listening to noise, or listening to nothing. So 3 conditions, very simple block design. And you see on average, plotting the average of these 10 subjects, event-related average looks very, very good. You don't have to, you can disregard the amplitude because this is normalized data, Z-transformed, so the absolute values might look very, very smallish, but this very much depends on your previous normalization and data treatment. But in principle, from the shape of the response and the time to peak and the peak itself looks amazing, very good. But now I want to know more. Now I want to look into the different subjects, and this I did here. Now I plot the data of the different subjects, and you immediately see subject 5 is outstanding. So it's really an outlier in the quality, while all the other ones have, in principle, more or less a shape that could look hemodynamic, but there are different 3 or 4 subjects which look really, really bad. So they have no clearly detectable event-related average in the standard fashion. So they go even down, which for Oxy is a sin, so it should never happen, right? But here it happens. So now we go further and analyze those subjects in a graphical fashion, so we can plot good and bad subjects, as I simply called them, very easily. Again, all done automatically, right? So you have the data, you plot it in any way you want. But this is something you would never get that easily by some intrinsic functions. But after you get the data in the simple format, like exported event-related averages, you can do whatever you want. So I swear to you, everybody, it will take you 5 minutes to do this, or 10 minutes. Then you might need 10 more minutes to test it out, or maybe half an hour, but you get it that easy. That's the idea. Now we look at the peaks at these channels in this channel for all these subjects. So now you see on the x-axis all the 10 subjects, 1 to 10, and you see in the gray and red and blue colors the peak values of those in those conditions. And you see very nicely again the same pattern here. Subject 5 is amazing, and in here subject 5 has a massive effect of speech. That's the biggest peak value. It's a z-value. It's 3 standard deviation units. That's what it means. While the other ones partially show a nice consistent effect. So in the optimal world, it would be like the red curve or orange curve would be noise, would be down, then blue, then gray, right? But it's not happening for all the subjects. And you clearly see some are potentially outliers, like 9 and 10 look not so great, and some others too. So there is variation in the subjects, which is to be expected. But we would not see the data otherwise if we just would run the second level statistics, because the second level statistics, in the end, in the worst case, is one number, which brings everything together. But now we look really into the dynamics of the event-related average, and we allow ourselves to identify problematic subjects or channels, or even run new statistics, because now we could run statistics on the event-related average characteristics if we want to do so. So now look at the time to peak. Time to peak, again, is the time it needs to reach the peak, not the peak itself. And here we see, again, now basically a high bar usually is good. Here a high bar is not good, because it means when you have a peak at 25 seconds post-onset, it's not an expected hemodynamic response, it's some other stuff, right? So it means these are subjects, again, 9 and 10 are not so great, but also 6 and 2, they are not really good. So it means you find already some subjects show a weird behavior in the event-related averages. And all those details you would never find without looking at the data in this detail. But of course, you would never do it if you would have to do it by manually clicking on the time course, extracting event-related averages, then using Excel to do something. You need an automatized way to do it. And this is what we want to provide you with. You can, now I went a bit overboard, because of course, as soon as you use AI tools, which I explain a bit later, but you will also get offered, oh, try this new plot, right? So the plot on the left, I just put in there for Geo, because I think he likes these plots. But we also have this heat map on the right, where when you look at the 3 columns from left to right, it's the CNR value, so contrast to noise ratio. This is now again the ratio between the mini peak time window of the event-related average and the baseline. Then you see if it gets fairly red, it means it's a great contrast to noise ratio, a fantastic effect. While when it goes to rather kind of mild orange or even blue, it means it's lower, or at some point even negative. And the basic idea is, of course, that if you look at the top channels here, S6 and S2, again, S62, they have an amazing contrast to noise ratio in the speech, and it's sorted in the proper way, so it all makes sense. So again, it's another measure that you could utilize further. Which of these measures you use, we cannot tell you. You have to find out. But as soon as you have all these measures, you can really choose how much they make sense also in combination. You could even be a real scientist in a way that you could even create your own measure. You could say, oh, now I want to derive a cool new measure, which brings oxy and deoxy together and calculates a new measure on the basis of the combined peak and the peak time to peak or something like this. So there's a lot to build on. Now, to sum this part up, I want to look a bit more into statistics in the sense of we all do GLM analysis and follow-up analysis, for instance, ANOVAs, soon to be expected in Satori. But most of us know that all of these methods come with a price in the sense of they are built on assumptions, model assumptions. And if those assumptions are not met, we don't really know what happens, or we know what happens, but we cannot really see it in our data because these assumptions might not be met, and therefore our t-values that we get in the end might be horribly biased and not really valid. And this is just an overview of what is relevant for the GLM, for instance, the assumptions about the normality of errors. And this is something you can now very easily also check by exporting your data and using either a script, or now I do it with JASP, because I also mentioned JASP in the beginning. So in Satori, you can now run the GLM, but also save the residuals. So if you click this little check mark, which is not the default, you get the residuals. And the residuals is just a little reminder here, is the errors that you get when you subtract the predicted data from the real data. So basically specify a model, the model is leading you to beta values, and the beta values are weighting your model in such a way that you get a prediction, that's the y hat, and if you subtract the y hat from the y, you get the e, which is the error or the error term. That means this is something that you can also save and plot, and Satori saves it now as NIR file. So when you check mark this little option there, you get a new NIR file, which is called _residuals. So you can find it in the folder of the data. And then you can do new analysis. And what you see here now, just to show you some a very unimpressive example, but the logic is solid. You can use JASP, for instance, to import these residuals and run a test against normalities. What you see now is multiple plots. The one is, of course, very famous, the QQ plot, quarter, but you also see a plot with a histogram showing you how well is my residual behaving with respect to the normality assumptions. And on the left side, you see very nicely the raw data is, or the residuals of the raw data are not normally distributed, which is totally explainable because all the noise is still in there and we know the patterns of the noise. So that means all the relevant tests you can do, most of course the Komodorov-Smirnov test, show you a significant result, meaning the deviation from normality is so big that it's regarded as non-random, so it's a significant difference there. And that means technically we cannot run the GLM on the preprocessed data, on the raw data, which we know, of course, but this is one of the nice tests why you should do this. On the right side, you see the preprocessed residuals, meaning this is the data after we do the standard preprocessing pipeline, and we see there's no significant difference to normality assumption, meaning also in the QQ plot, it looks much more closer to the diagonal. So that means we get a green light, at least for the GLM. There's other tests, unfortunately, we should do sometimes, but we don't do, but the scripts will also help you to run these tests outside, either within the statistical package, or if you are like more bold like me, you can also try to put this Komodorov-Smirnov test into a Python script, right? So you can export the data, run everything you want into your Python script, and get these results out automatically without even opening Python, JASP. But if you have JASP, of course, you can use it to test your scripts, which I would highly advise. Whenever you do something new or something you don't yet fully understand, always have a plan B or like an alternative method to calculate the same thing and then compare it to whatever you create. Here you see just a Python-generated script of the QQ of one channel in the fresh data, and there you see again very much differences via these raw and preprocessed data, as expected. Good. Now we go to part 4, which is the re-importing of the data, because I showed a couple of things to export and to use it externally. Now we want to get back to Satori. So in principle, you have multiple options, but I started this already by creating a little script that uses the CSV files that are exported from your external statistics or another Python script and injects it back into another CMP, because I mentioned the CMP is the relevant structure in Satori. So the channel map in the end is what you have to create, but you don't want to create it by copy and paste by using a mouse or whatever. You could do it in principle, it's not impossible, but it's not the best way to do it. So this script helps you with a couple of steps. So when you start it, you can, for instance, load the peak value that I just mentioned for the ERA. So event-related averaging peaks of a lot of channels. You grab them and you put them into a new CMP. And now I look at multiple channels. So for instance, here, look only at one channel, which is S12D12 on the right hemisphere, auditory cortex. You see very nicely that there is a fairly nice peak, 2.8 to the 9. Again, it's z-value, so it's not directly, in a sense, that it is a kind of statistics, but it's not a t-value, but it's already normalized at least. That means you can immediately compare it between channels and also in a way between subjects. And now you can compare this, of course, also nicely with other channels in the same data set or between subjects. We could use now this function to create, again, what I said before, a second level statistic. So that's not very easy. Good. Before I get to the summary, because Francie, how many minutes do I still have? Because on my watch it's 30 minutes about, so I still have few minutes left, I hope, right? Good. Okay, let's quickly jump out here because I want to quickly show you, hopefully, that it works in real life. It's not just on the slides, so to say. So I use now the latest Satori version, and what I do is now very simple. I start Satori and visualize a couple of scripts here. And as you can see, I have a bunch of scripts in here. Your Satori comes with this standard pre-installed scripts that do a couple of things, but you could easily add your own scripts. And now I use them at the level of single subject, so basically single data sets. But of course, the script that I start now could already do some batch processing. So if you want to do multi-subject processing with one script, you could already do it here, or alternatively, you can decide to add your script to the workflow manager. So you could even do this, which is another cool way to make your scripts multi-subject capable, so to say. And what I start now is I run this script, CMP inject metric dialog Satori. And as you can see in the name, I'm not very creative. So I usually just choose what the AI gives me, but I sometimes adapt it a bit. But in principle, the idea is you can start it without a sneer file. And you see it only after restarting Satori when copying the script into the Python scripts folder. So you don't see it immediately, but you have to refresh by starting Satori. This might change in the future, but right now you have to restart. Then you see it. And often when you start the script, also important to note for potential Python newbies like also me, it might take very long in the beginning because DLLs have to be loaded and the script basically has to prepare its processing. So it might look, oh, this crashed, this didn't work, but it's still processing. The second time you run it in the same go, so to say, it's much faster. And what I do now is I open a folder from the fresh dataset. As you can see here, it's all the fresh subjects. I created a quality evaluation folder, and this contains a lot of files I created already, as you can see. And now the thing I do is I choose a dataset which is event-related averaging output already. So I don't start at the time courses. I start now at the event-related averages because I want to calculate something on the basis of this. So I load this file here, which I know contains the peak values and other statistics of the event-related average for this subject, but all the channels. So I load this file. It will take a little while, and then it should give me this new dialog. And then here you read select CMP file, because now to create a CMP, I need a canvas, I need a dummy, or I need a setup, a montage, because I cannot create the CMP myself directly. I could maybe do it, but it's not advised. Just use a prepared CMP file. And what I did, I just ran a seed correlation to get just a simple CMP I can load here. So I just looked this up. This is this file I loaded, same subject, same montage. You could use the montage from another subject from the same measurement. The only important thing is you have the same number and assignment of channels, and then it works out fine. So you load this file, and now the script prepares something else, because now you have to select what you want to depict. And now you see already the script looks into my file and gives me a lot of information that is in the file. First, I want to select the column that contains my labels, like the source detector labels, and this is of course channel. Then it asks me for the numeric value that I want to inject into my CMP, and here I select, let's say, I don't know, peak value positive, which is the peak amplitude we discussed before. So I open this, and now finally it asks me for the condition column, which is, I could just automatically do it, but now I just do it with this dialog to show you. I select condition, and now I can select a condition, because I can do the same thing now for all the three conditions. I want to just do it for speech now, because it's the most relevant condition. And now finally, I give a name for the map. It's peak amplitude or something, peak amp. And then I save it as a new CMP file, which possibly opens up now. So now I can just, do it on the basis of this map. So I just call it peak amp.cmp, and you're done. That's it. right? So now I can go into Satori. I open the, of course, I have to open the sniff file to show my new map. So I just open the same subjects. I can use the raw data or the preprocessed one, doesn't matter. Only if you want to also look at time course, it makes more sense to use the data set that you also use for extraction. So I load this data set, I wait a bit till this is loaded, and I then go to overlay channel maps, and I load the newly created map. And of course, now you see there's a bunch of maps I created in here already to test it out. And now this peak emp, as you can see, all those maps are super small. I load it. And after loading it, you see automatically it has this simple name I use, peak emp. And one more thing, if you are wondering about the coloring scheme I usually adapt. I don't use the same colors I use in this classical T map, because just by looking at the map, even without seeing any value, I want to warn myself, this is not T values, these are Z values, these are peak or latency values. This is something new, so you can change the color scheme. This means now that, of course, you can go into your 3D view here and visualize everything. And depending on the color scheme that you loaded, and you can load it here in the preferences, you can go to data and load a so-called OLT, which is an ordinary lookup table. It's an assignment of numbers to colors. And what I use here is, I don't know, red, green, or whatever. You can, let's say, I don't know, maybe some are better. So you have to try this out. That means there is no best that we can immediately tell you, but you'll find it out, right? But one more important thing is that the assignment of the range here now should maybe best be checked by this. I could also automatize it in the future, but right now I see the minimal value, the maximum value is here at a certain point. So I would then at some point, of course, adapt it here. But now in this case, if it is okay, I can leave it like this. But depending on how you set your range here, which you can do by setting the threshold manually, you will get a better or less good representation of your more or less fine-grained differences between the brain areas. That means if you choose the wrong value, maybe everything looks light red, but you don't see any differences between the channels, but they should be there. And of course, you can always find them out by setting a proper range here, adapted to the values of your current map. And of course, you can always click on any map here, or can choose a channel here. You see now, for instance, there's a certain value of this channel in a certain size. You see the bars coming up depending on the threshold selected. And of course, then you can always depict this in different ways or adapt it. Now, threshold is already set to 0, right? So depending on what value you export and how the data looks like, you will get more or less nice looking differences here. But the basic idea is just to tell you, you can now very easily not just create these outside values, but also import them back and now run new analysis on these. Or you decide to do everything outside and just as the final step, you import everything back. So the map could, of course, be also one created on the basis of a second level analysis, which this is not yet. But I have a batch script that runs this map creation on the basis of as many subjects as you like, because it just selects the folder, and based on the folder, it brings everything into one CMP to save it at the end. So now let's finish the slides. That's the second. Go back to presentation. Okay, to summarize, and hopefully to say in time, you hopefully can see that exporting all kinds of data is fairly simple and effective in Satori. And we mean it not in a way to show you, oh, this tool is very, very limited and should do 90% outside. We mean it in the opposite way. We mean it to basically tell you the world outside is always larger than your own world, right? It's the same as if you live in your apartment or your house. I have a big house, fairly big, but the outside world is always bigger, right? That means you live in an apartment, you live in a house, there's always more outside. That means the way to the outside is important. So if your door is locked, you have to live in your house, but if you can open the door, you can experience the whole world. You can travel to Cuba, I don't know, to Hawaii. So the outside world is always more interesting in a way. But we want to help you there to get there. So to choose the most effective tools, what we want to provide you with is tools that can make it as easy as possible, even for complete non-programmers, to export those data and to even already analyze them in any way you like. But of course, the first simple scripts could just be scripts that sort your data differently or bring it together. Let's say export data from 10 subjects. You just want to collapse it horizontally or vertically. That's the perfect job for a script. Or you want to rename it, or you want to normalize it differently, whatever, or you want to just plot it. So no real calculation involved. That's the perfect starting point. But the main idea is we want to help you there. And of course, the goal behind it is you get better by just understanding your data better. And that's what also always Gio presents in his talks about analysis. The first step is to look at your data. But looking at your data is linked to the tools that you can use. So when you use Satori, it's already a great insight into the data, but it's of course limited, as I mentioned. But using these tools, the view at your data will be, I cannot even tell you with which factor a trillion. So that means you can only win by doing this. And really, it's a big change for everybody. I can only speak for myself. I do data analysis for nearly 30 years, but using these combinations of tools is a game changer for everybody. When you create scripts and use them, you can use them either outside, of course, of Satori. You could also run perfectly everything from a command line or from Spider or something from an editor for Python. But you can just copy the scripts to Python and do it from there natively. But you can also add them to the workflow manager. And if you want to do so, we can help you. And finally, we want to have a little plea to you. So basically, that's the communicative part. We don't just want to show you what's possible, but we need your input, because as smart users, we need input basically first and most important in the sense of questions. So if you say, yeah, I like this Satori, but this part is missing, how can I do it? Please ask this, send us an email, get in touch, and then we can help you with either sending you something that is already existing, or we can work on something. Because I have a ton of ideas, but many are stupid, but every day I have a million ideas, but I have to find out the good ones. But by getting better ideas pre-filtered, I can actually structure my day a bit more effective maybe. And we can all work on this project together. So integrating the users is one of the most important parts of this. We want to, of course, grow the community and make the existing community more powerful. Good. And because I want to tie up everything with a musical bow in the end, because I started with the police, please keep in mind we are at the beginning of this enterprise, so there's still a lot of roads to choose. But of course, hopefully most of them are really fruitful for you or interesting. But I'm pretty confident that we can reach this if you stay in touch and try out things. And please, one final word, please don't be afraid. You cannot break anything, you can just learn something. So it means when a script doesn't work, nowadays the important point is I open my heart now, so to say. So I was never a great programmer, but I'm still not. But with the help of AI, I can shift all my resources to the planning stage. So I know exactly what I want. I know it absolutely 100%, but I could not bring it in the code in the time I have of my life. So I'm old, so I need to do everything, make it very fast, right? Hence, with the help of AI, I get the power I need to have in my brain. I have it now outside. You have to be aware of problems. We can discuss this later. So you heard the term of hallucinations of AI and of errors that are made. Absolutely. But we can help you to evaluate stuff. And of course, everything we provide you with in the beginning is verified scripts. That means scripts that are tested and checked by us. So it's not some garbage that I did last night while I was drunk or so. I don't drink, but just as an example. Then that will not happen, right? But please help us get in touch, and we can build something up together. That's basically the idea. But I think I'm done now, so it's still in time. I hope. We have still time for questions. Thank you.
Wonderful. Thank you, Armin. Thanks for this wonderful presentation and this very nice demonstration of the Python integration. Really nice to see. Yeah, so we received a couple of questions before the webinar, but if you have any more questions, please feel free to type them in the chat now while I will start asking some of the questions from my document here. So the first question, Armin, would be, can I export NIRx Wings 2 data independently from the FNIRS data for separate physio analyses? If yes, how would I do this? And maybe for everyone who doesn't know yet, the Wings 2 is our physio device that allows you to record all kinds of physiological measures alongside the FNIRS into the same data file.
Yeah, maybe I can already start. So it's a very good question. I already looked into this myself because I was also interested, because what we offer right now in Satori is a very useful, but of course, again, limited option to use the physio data in the context of the GLM controls. So you can use them right now immediately, but they're not as such used as their own dependent variables. So you cannot with one click export them and run your additional external analysis. But of course, that could be a first new script that one of us could create, like just extracting the physio data from the file. But we have to be a bit careful here because, as you know, or most of you know, the physio data has its own specifics, so to say, different sampling rates. It has for the analysis, it has to be synchronized with the NIRx data and such. So whatever you do outside is, of course, potentially very powerful, but you have to keep these details in mind. But it's, of course, very easily possible to export the data. You can also, I think, just export it from the NIRx editor. After opening it up in Satori, you can check it out and export it from there. But it would be maybe even easier to say, oh, I have the script now as a NIRx reader, but then it's an fNIRx physio reader or something. So it exports with just whatever physio data you have. Then you have it in a CSV file or any format you like. And then you run your own filtering there or statistics or plotting. Absolutely.
Wonderful. Yeah, I also want to add to that, just from a recording side, actually. So the Wings data is also always saved separately outside of the SNRF file. So in your data folder, you will find a .wings data file, which is just also, I believe it's a CSV file. And then you can look in the Aurora manual. It tells you which column is which. There's like assignment for which column is which sensor, and then you can also just go from there. So you either have the option of exporting it separately in Satori, or you can just use the Wings, the Wings data file. I see there is a question. Someone raised their hand. I'm not sure if you would like to unmute yourself to ask your question. Maybe so we address it directly. Okay, so maybe you can type out your question in the chat instead, or okay.
I can make a question on the peak analysis that Armin just showed. Does that have a meaning to take all the peak and heavy trial of the task and do a contrast between different channels only on the peak? So like I have 7 trial and I take every peak, I average them and the contrast between channel this kind of data or not?
I hope I understood it correctly, because what I showed you so far was even simpler, because I first did the event-related average overall, which basically averages over all the repetitions, and then I extracted the peak. You could do it in the other way around. Actually, you could extract first every peak and then average those, or you could even say I'm interested in the differences of the repetitions. So you could compare the peaks of the different trials. So all is possible, and of course, everything you extract can only be prepared in a way that it separates the trials, because in Satori's event manager, you have these nice tools now where you can split your repetitions into separate conditions, actually. And then you get, instead of one condition, you get 5 conditions, because you had 5 epochs in total. For each of those, you get an event-related average, and with this a peak. So you could also extract those and calculate those, for sure.
Okay, thank you.
Yeah, sure.
Wonderful. Then maybe next, I see another raised hand, so I would address that one also. Nick, would you like to unmute yourself?
Yeah, Armin, great. Can you hear me okay first? Sorry.
Yes. Thank you. Yeah.
Armin, fantastic presentation. Just hopefully quickly, and sorry if I missed this. Are the scripts, some of the scripts you showed available? It's just the way you talked about it made it seem like they're available, whether through GitHub or
Yeah, perfect question. So as if I ordered it, because I wanted to talk about it but forgot about it. But Michael also mentioned it before when we talked with him. I'm not sure if he's here, but he's of course the creator of Satori, so I'm supporting it, but he's the creator. And the idea is the following. Maybe I can quickly share my presentation again, because I had a slide on this, but I didn't show it. So just to not to bore you a lot, but just to show you the options, because there's always multiple options. Sorry, I'm not at the right spot. Can you see my screen?
I see yourself.
Okay, not my screen. It doesn't matter. It's all good. So there is, in principle, right now 2 options. let's say the safe option would be if you are willing to wait. You wait for the so-called verified scripts that come with the next Satori update 2.4. And then everything is tested by us, works hopefully beautifully, tested by not just me, because I could overlook a lot of things, but very experienced colleagues on different computers, different data sets, verified and can be immediately used. Second option is a bit more for the bold or like trial happy ones like me. You can ask me for anything I tested out. I would send you everything. But of course, we should restrict it to the stuff I tested myself at least. You can try it out. And of course, by this, we're also learning a lot, because we learn how easy it works on your side to set up based on your background, based on your data that you use. So with every interaction, we learn a lot. So that's the second mode. So we just contact us via email. I would show you the download stuff. You download it. Everything that we provide now comes with a little instruction. So you don't have to use it blindly, but you know where to put it, you know what it does, you know especially what it asks for. Because for me, all these scripts are completely clear because I did them over time. But if you start the first time, it will ask you for stuff you don't know what it is. So it should come with a documentation, or at least the dialogues are so nice that you just have to read through it. Or it does everything automatically, but in any way, there has to be a documentation. But if you want to test out, so I think we are very free and happy to share with you, because then you will be the builders yourself. So you can, of course, then start the script. And what I would, for instance, do, if it gives me an error message, like I had a very nice error message today in Satori, which was a weird one because the script still worked, but gave me an error message. So I just copied the error message into the AI, and it told me, yeah, this is because, I don't know, your last script ended on a term that Satori interprets differently. So it means just change it, and then it works. So you can adapt stuff yourself, or you could broaden the functionality. So it works in any way. If you contact us after the webinar, just send us an email, and then we can send you whatever you like to use. So right now I have probably about 100 scripts, but they are partially more or less usable. So for instance, to give you a simple idea, I want to test how easy it is to create regions of interest. So let's say it's just a script that loads in a file, and you just can enter, I want to average these 5 channels. I want to average these 2 channels, and you just get a new, in my case, you get a new CSV file, but you could also, I didn't test it yet if I could directly, I mean, I don't want to create a new SNF file, but I just want to stay outside then from external statistics. So in this option, you cannot easily go back to the nice surface visualization unless you do some workarounds. But for external statistics, it's super simple. But just get in touch, and we send you whatever you're interested in.
Wonderful. So, thank you so much for that.
You're welcome.
Okay, beautiful. So we are on time now with the hour, but there are still many, many questions. So I would keep you here for a little bit longer, Armin, if that's okay. And whoever needs to go, you can hop off, and this recording will be uploaded to our website in a couple of days. So you can tune back in. Perfect. Maybe to continue with with a more simple question, Armin. I think you skipped it because it might be a little bit, like to you, it might be very intuitive, but how can I export images with Satori?
Okay, yeah. So it is intuitive, but I mean, right now you have the also the export option in the export menu, and let me see if I can again share my screen. Just a second. But yeah, let me see it better. I hope you can see my screen again. But there is the export screenshots option, and there is in the moment still, but Michael can explain this much better than I. There is the very easy option to save the 2D views, but in the moment the save 3D views, it's not based on our fault, but based on some technical limitations. The 3D views, which for many people is the most like sexy depiction of the data, is not possible right now. Will be possible maybe at some point, but not right now. So if right now I wanted to make a very nice visualization of the surface with my activation or with whatsoever data, I would create my own screenshot with an external tool. So it can be any tool of choice, but of course your screenshots usually have to fulfill certain quality limitations. So you better choose then maybe something that works best for you. But in the moment, I would do some of them from here, but others I would do with standard screenshot tools. And of course, what I mentioned before, you then can, of course, also very easily create your combined external pictures or images with maybe a combination of some Satori and some external screenshots. So whatever you want is then possible as soon as the data is out. But maybe Michael, you wanna add something because you're here for the export.
Yeah, we are trying to get this sorted out with the 3D view. So on the long run, we definitely completely changed the backend for the 3D viewer, and then it will work for sure. Currently, we would just get a black screen, so therefore it's disabled in the options. But as Armin said, you can do a screenshot of your screen in general. In combination with the tools in the 3D view, you can change the background to white and like many different other things as you like it, and then you can still work on the picture with your favorite screenshot tool, basically. But here, if you go to the background color and change this to white, which is maybe for some of the publications not too bad, you have a bit easier time to integrate this into your articles, for example. It makes it just a bit easier to have this in a figure. But we try our best to include also the 3D view as an output image with the options to change the resolution so that it's not dependent on your screen.
Yeah, unfortunately, maybe one thing from my limited perspective on this, I dabbled a bit with this whole screen resolution versus PPI or DPI resolution. So that can be a bit of a nightmare when you start from the wrong side. So I mean, ask us when you have very specific wishes. Always ask us. We can help you because we had the same pain before, probably. Please get in touch.
Wonderful, thank you. Perfect. Then maybe a next question that also quite a few people asked, Armin, and maybe you can address this just very briefly. What about group statistics or multi-participant GLM analysis?
Yeah, excellent point. So I skipped it over because of now I know because I talked so fast. I could have edited, but I didn't want to. Then I would have talked even faster. But so it's a complex topic. So let's start in the beginning. But Michael, please interrupt me anytime when you want to add something. Right now, the idea is in this current version that I'm using right now. So before the switch to the next major update to 2.4, in this version still, I can use the multi-study or group GLM in such a way that I can add all my subjects in here. I can check mark the separate subject predictors option. That's one way to do it. And then I get in here in Satori directly the option to run like basically a one group multi-subject analysis, meaning if I have two groups like patients and control subjects or men and women, old and young, experienced and novice people, I would not be able to directly compare them in a statistical fashion, but I just collapse everything into one group for the same. That's one way to go about. So the solution for now is if you're stuck to this version and you have to do it like tomorrow, what we would say is use our support document, run this GLM anyway with all your subjects. So first put all your subjects together here, run your separate subjects GLM, and use a very simple workaround to extract all the associated beta values that are stored intrinsically in an Excel sheet. Again, it's done with the help of a Python script, which comes now as an executable actually. So it's even for people who don't want to or cannot use Python, can use this executable. So it's all linked in this document. But this tool helps you to rearrange the data in a way that you just get the beta values, and the document describes in great detail how to import these beta weights into JASP and then run your, for instance, ANOVA with a group factor in there. So that's the solution for the moment. Upcoming with version 2.4, there will be an ANCOVA module, which allows you then to run the group statistics as part of an ANOVA structure, so with the between subjects factor automatically within Satori. So you don't have to go outside anymore, but you can do it all inside. So right now there is this limitation, but this limitation is easily overcome, and we show the way to do it in JASP. I'm currently working at a document how to do it in R, because it's a slightly different way to do it, but more powerful in a way. I started with JASP because it looks nicer and easier to do, but we can do it in any tool you like. So you don't have to do JASP or SPSS or whatever we choose. You can choose your statistics tool, but the basic idea, what you get is this, you get this output, and maybe sorry if I jump around now, but I just want to show you. I'm not telling you any stuff that is not there. It's all available. There is a document that is. I just have to find it. But okay, it's typical. but it is, where did I put it? Shouldn't have done this, but rest assured, there is a very extensive document that I can send you that really shows you all the steps from A to Z, from exporting the data to reformatting it and then to bring it into your software. The only thing you have to keep in mind is you have to think a bit towards the end with the workaround. Where do I end up in, and what tool do I use in the end? Is it SPSS? Is it R? Is it something completely different? Is it MATLAB? Is it a Python statistics toolbox? How does it want the data, right? Because what you create here is a probably massive file with beta values. And the cool news is you can, right now, even in this version, you can also do it in the workflow manager. And that's even more advanced, because in the workflow manager, you can run even the biggest type of GLM. Let's say you have 1,000 subjects, but totally unrealistic. But let's say you have a lot of subjects. This multi-subject GLM that I just showed you, at some point, we know this might create problems in the domain of the working memory of your RAM. And using this approach here of loading your data and then running basically a sequential subject GLM, single subject GLM, basically by loading all the subjects one by one and running the GLM for all of them one by one, which is another practical way to handle the analysis, gives you those exported betas right away, and right away in the proper fashion. So it means you don't even need to go this route of boiling down your complex output file from the GUI-based multi-subject GLM to a smaller file. Here you get the smaller file immediately, and you can run it for more subjects. But those both ways are described in our documents, and you can easily follow them. And we help you with every step. But if you wait a bit in the update, the Uncover module will be included. But for now, I would try it out. And I mean, I have a bit, because I'm now in a kind of Python hype, I will probably try to create some simple ANOVA in Python, or I will try out the available toolboxes there, and then we can document it better for you, so you can also jump there immediately. But also then add the information of how to, because then you get an F map, or you get an F value for every channel, and then you have to import it back to Satori via pretty much the same way I showed you before, but just using F values instead of CNR or peak value data.
Okay, great. So I would say let's do one or two more questions. I also see that there are quite a few questions in the chat. Again, don't fret, all the questions will be addressed. If we don't get to your question now, we will answer them later after the webinar and write you a follow-up email. I would like to ask another question that was also asked twice. So what about visualization of functional connectivity and export of such measures?
Yeah, fantastic question. So, I don't want to point to too much stuff that is coming up, but Michael can also explain more about it. But we have to, yeah, I'm super interested in this field in general, so that helps a bit to also test out stuff. But right now how to start this? So I would say regarding so there's two fields, I would say, the subfields, the analysis and the depiction of results, right? And as regarding the analysis of functional connectivity, I think we are now entering a new domain where these tools are added. So right now, in the very, very modern, with this version, I would say, if you want to do functional connectivity, you can do some limited types of functional connectivity, like you can do this, what Satori calls the cross correlation here. So correlation between all the channels in your data set and store it very nicely as the resulting text files and can work with those. But you can also very simply do analysis techniques like, for instance, a PPI, so a psychophysiological interaction, GLM, which is a type of a GLM analysis, also well described in the support document. But you cannot yet do very complex analysis types like wavelet and wavelet-based analysis or stuff like this. But it is being worked on, also in the context of hyperscanning data. So when you have dyads of subjects or larger groups of subjects which are doing, where you have measured them all in a connected fashion and you want to analyze them all together, this is, of course, more complex data that should be treated also in a complex fashion. So there is a lot of different measures for the depiction of the data that comes, of course, with a bit with a specific domain. So let's say in the context of a kind of purely correlation-based, which might not be Pearson correlation, but another type of correlation like robust correlation, to do this type of approach, you can also in the end simply depict a correlation map. But you can then also try to make it a bit more interesting in different ways. So what I'm currently looking at is how other tools are doing it. So for instance, there's multiple tools. There's, for instance, one connectivity analysis tool, NIRx, which you can try out and test out. It's also running with MATLAB runtime installer, so it's relatively easy to install. But I have to say it's fairly easy to use, but it's not working that great, at least for me. So that comes with the price of a free tool, I have to say, in a way. But it works in a way, so there you can also get some inspiration how to plot stuff. We are also in the moment testing this. For instance, for the larger context of the hyperscanning data, there, of course, you have to think about completely new visualizations, where stuff like we do now, like showing a single 2D and 3D brain representation doesn't do it anymore. They need to have something like pairs of subjects, like dyads that are represented where their connections are represented in any form you can think of. Or you need to look at tools like it's called the BrainNet viewer or something. So there is already tools for different types of data like EEG and fMRI data, where you can depict connectivity between regions of interest in the brain in very cool ways. But we are currently looking at this. But maybe, Michael, you want to chime in, because it's really an emergent field right now. So we are currently, I would say, in the moment of getting better prepared, but also starting to implement.
Yeah, exactly. So the main point Armin addressed already. So we're working on many different aspects of the functional connectivity, but that also includes that we're working on the research ourselves. So we're trying to replicate some connectivity studies in Maastricht, and this will also, of course, use Satori and some new features that will be then available to everyone. But this is then part of a bigger publication where we also basically figure out which of the tools is the one that is giving the most consistent results. And this will also include independent component analysis, for example, and different types of seed-based correlations that Armin mentioned. And this will then also result in a different visualization of these features in Satori. And next to that, we're also working on the wavelet coherence, which should be also available just by a button press. I won't show you the current version of it, but it's in good development, let's say it like this. So if you're really interested, just be a bit patient for us to make these things all work out. But generally, it's always good for us to know in which topics you're interested in. So it's always good if you just drop us an email that you're interested in a certain feature. That helps us to align certain developments and set certain priorities a bit easier. Currently, we are using all the input we get from conferences and from feedback that you give us. So that's really, really helpful for us to improve these.
Okay, wonderful. And I think we're 15 minutes over time, so there are more questions, but I am going to end it here. Otherwise, I think we could all stay here for another hour or so. Thank you very, very much, both Armin and Michael, for this very nice webinar. Everyone, thank you for your attention, for joining us. As I said, all questions will be addressed, so be on the lookout for an email from us. If there's a question that you asked that we did not get to. And yeah, I wish you all a great rest of your day and happy exporting with Satori and back into Satori.
Happy scripting. Thank you so much.